Hey everyone, this is Stefana Muller from Upsani. I'm a developer advocate. And with me, I have Stephen Quintero. He's a software engineer at Upsani. He's going to talk to us a little bit about deployment verification, internal and external health checks. Ready, Stephen?
Yeah, so today we're going to give a short demo of deployment verification using a Docker Swarm stack. And our demo stack for this is a simple WordPress application. And you can see here on the right of the screen, we have a Docker Compose file for the stack, which includes two services, a MySQL service and a WordPress service. This stack file includes internal health checks for both the MySQL and WordPress components. You can see these are defined here and here. And we call these checks internal because they are executed within the process space of the container. Container built-in health checks are another example of internal health checks, which are baked into container images. So these internal health checks do a pretty good job of verifying a service is properly deployed from the point of view of a service itself. But internal health checks cannot verify an instance properly exposes its API or service externally, as it would be consumed by other services. So because of this limitation, a failure of one service may sometimes be reported as a failure in a different service, which is actually healthy. And our demo today examines how one such failure case unfolds. So to get the ball rolling, let's deploy this WordPress stack in its healthy state. And so we'll start with a Docker stack deploy using our stack file. And to see progress, we can do Docker stack ps and the stack name. And we can see that the MySQL component is running and the WordPress component is still starting up. Now they are both running. And if we take a look, we can see that the WordPress component exposes its user interface on port 8080 on the Swarm. So we'll take a look at that now. And we can see actually we have our WordPress UI working. So now that our app is in a working state, let's get ready for our failure test. So in this test, we're going to upgrade the application while introducing a failure in the MySQL component by including a config file which binds MySQL to listen only on localhost. This is our config file. So this is a human configuration error, which disables external network access to the MySQL server. And let's see how this failure unfolds when we do a Docker stack deploy. So first, let's do an upgrade. We'll change the MySQL version to 5.7 latest and upgrade the PHP version on the WordPress service. We will also include our MySQL configuration file on a mounted volume of the MySQL component. So our config file lives on this volume and it's being mounted into that directory. So now we've basically set up our failure test case. Let's go ahead and deploy this change. We'll do Docker stack deploy. And we can do PS again to see how this deployment unfolds. So we can see right now, both the services are restarting with new instances because of the upgrade. And we'll just take a look at how this keeps going. Here, the MySQL server is running and up. We can see that it passed its internal health check because that check is performed within the process space of the container. And in fact, this command, MySQL admin, can ping the MySQL service internally. Take another look. We can see that the WordPress container has failed its first attempt to start. And that's because its health check, which makes a curl request to localhost, failed. That request failed because it cannot access the MySQL server because the MySQL server is only listening on localhost. We can see here we configured our health check to retry twice. And so we don't spend a lot of time. We've told it to make one attempt to retry the entire restart.
So Stephen, the MySQL server is the thing that is misconfigured, correct?
That's correct, yeah.
But the failure happened on the WordPress server. And is that a failure of the health check, a failure of how we implemented the health check? How does that work?
Okay, so basically, because this health check is being executed internally on the MySQL container, what that means is it can't actually tell that it's no longer externally accessible. And so this internal health check actually passes, but the MySQL service itself is not listening outside of localhost. So the WordPress health check fails as a result because it can't get its default page because WordPress can't connect to its database. So while the failure has been injected in the MySQL component through this configuration of a MySQL config file, the result of this failure actually bubbles up in the WordPress component as a deployment failure, namely an internal health check failure on doing the application upgrade.
Oh, so you have to be an investigator to figure out the actual problem is not in WordPress.
Yes, here we can see we've finished doing our Docker stack deploy. And yes, the actual problem is not in WordPress, but we can see our end result is the MySQL container is left running and the WordPress service has failed all of its retry attempts and is left in a failed state and shut down. And if we take a look at the UI, we get nothing. So this is a case that shows the practical limitation of internal health checks, really because of the way that they're executed, which is to say within the container itself. Now, to get around this limitation, we're next going to take a look at how the same failure case unfolds using external health checks. External health checks execute a check on the service network of an instance and can faithfully reproduce the position of a client consuming that service. So this check takes place from the outside, and it can actually fully verify the instance is providing its expected API or service as it will be consumed by a client of that service. To take a look at these external health checks, we're going to use Scopus to try the same failure case using external health checks. Scopus is a modern continuous deployment system for container-based services, and it works with a single host Docker and Docker Swarm. And it does also provide external health checks for deployment verification. Scopus runs as a container on, say, a Swarm Manager node, and we can see that this container is running. And it exposes CLI, API, and GUI controls. And here we're going to take a look at the Scopus UI, which is exposed on port 8100 of the same Swarm Manager node. Here we have the same application loaded. And so we'll take a look at it. This is our WordPress app. And Scopus in the UI provides a graphical view of the model of the application. So we can see our MySQL component, our WordPress component, and also a cloud icon, which indicates an external gateway for the port exposed on the Swarm routing mesh. When Scopus is working with an application, it can tell if it has deviated from its target state. And in this case, it has. We can see both of these components are outlined in blue, meaning they're ready for deployment because there is a deviation detected. And we will be changing the WordPress version back to 7.0 and the MySQL version back to 5.7.18. So now to get the application back to its initial working state, we will just start the deployment in the Scopus UI, which will cause the application to once again be in conformity with its original model descriptor. So Scopus works both with Docker Compose descriptors as well as its own internal descriptor format. And it also does some useful things like deploying in respective dependency orders. So it will update MySQL first and then WordPress second. Here we can see progress on the MySQL container. Look at what's in here, 5.7.18. Oh, there it goes. Now we have used Scopus to return the application to its initial working state. And if we go to the UI, we can see once again the UI for the WordPress application is functional. Now that it is working, let's see how Scopus handles the same upgrade failure test. So we'll take a look at the model descriptor for this application, which is like a compose file. It's Scopus's internal descriptor format. But here we're going to make the same change that we introduced earlier in the stack file. We'll change the MySQL component to use the latest 5.7 version. And we'll change the WordPress component to use PHP 7.1. And at the same time, we will introduce the same volume, which contains our MySQL configuration file, which will inject the failure for our test case. Now that we've edited this descriptor, we'll just apply it. And Scopus recognizes that there's a change which can be deployed. When Scopus recognizes the change, it generates a deployment plan, which can be reviewed before actually deploying. So if we switch to the plan view for this application, we see the deployment plan will proceed in four basic steps. If we zoom into it, we can see it's a detailed component deployment plan. In this case, the MySQL component is stateful and a singleton. So Scopus generates a deployment plan which takes down the old first, brings up the new, and then if this deployment fails, it will roll back to the previous state through the cleanup steps, which are shown in purple down below. So this component plan detail is the visual view of the logical flow of the deployment process, which is broken up by Scopus and exposed to the user. The user can inject custom steps into this plan to do things like deployment verification. In this case, we did not have to because Scopus recognizes the MySQL component as a known public image and automatically injects a quality gate. And a quality gate in Scopus is simply a step which gates the deployment of a component.
So is this quality gate similar to the health check that we performed in the previous demo?
It is quite similar to the health check. The difference is that it's an external health check. And Scopus uses what are called containerized application probes to perform external health checks. And the Scopus probe basically packages a service health check as a container. Because of this, during application deployment, a probe can be instantiated and attached to the service network of a target component. And in this sense, the probe runs in the same context as the application and can faithfully reproduce the position of a service's client. And from this position, it can assess that target component or service externally. While we used the UI once before to do our Scopus deployment, we can also use the command lines. So now we've started the deployment, and if we look at the Scopus UI, you can see that it's in progress. The steps are chained to green as they're successfully executed. Each step has an error branch and a success branch. And as the step is executed, it will take one of those two. And depending on the result, either go forward to continue the deployment or go through a rollback and cleanup phase. So in this case, our upgrade of the MySQL component has taken down the old MySQL, has updated the new MySQL, and is now trying to perform the probe assessment of the new MySQL service instance using the Scopus probe.
And because it's an external probe, we hope that it fails. There we go. It fails right here, rather than waiting until it gets through the whole WordPress deployment.
Correct. So because it's an external assessment, it failed properly. It went back into the rollback phase and restored the previous version of the MySQL service. So the result of this deployment, as you can see in the command line screen, is that we got a deploy failed and a rollback. And because of the rollback, if we take a look at the WordPress UI, it is still functional. So the result of using external health checks as opposed to internal health checks is that we can accurately and even fully gauge the success of the deployment of services or service instance.
Yeah, well, because the deployment happened, it rolled back properly. We understood where the problem exists. And now you can go into your logs and start troubleshooting that specific MariaDB instance because that is where the problem exists.
Because that's where the problem is. And if we go to the model view,
yeah,
we can see that MySQL component is in red, its flag has failed, and this one has still not been upgraded.
Also, the interesting thing that we saw in this demo is that with Docker by itself, you have to kind of keep refreshing that screen to see if something happened and keep running that command. But with Scopus, I can see it right on the screen. That makes it a little bit more visible for me.
Yeah, well, the UI is a nice thing in Scopus. It gives you a genuine view of the model of the architecture of your application, which is comprised of, in this case, a really simple app with just two different services. But it also provides a plan view before you actually execute a plan, which will give you a detailed view of what will be done. And this plan is actually user modifiable. So while Scopus itself automatically injected the probe to do the external health check on the known MySQL component or service, you can actually define a user quality gate, which can be added also to any component to perform custom assessments, including the full verification of an API.
So would you think that, you know, I consider external health checks in two ways. One, it's bringing quality assurance all the way through the deployment. And the second is it's almost like operations, right? Where in the ops team, we're monitoring a tool and trying to figure out if it's up and running.
In this case, yes, it's providing basically deployment verification. One of the things that we do plan to do with Scopus is, in addition to simply generating deployment plans for deployment or upgrade, to extend that functionality to generate verification plans so that you can verify an app is more or less continuously healthy and automatically remediate failures if they do crop up.
Well, Stephen, that was a pretty thorough demo. Thank you for putting this together today. Learned a lot about deployment verification, the difference between internal and external health checks, and how to go about implementing both. So thank you for taking the time today.
Oh, yeah, sure. I hope it went okay.
No, it went very well. Have a good day, Stephen. It was good talking to you.
Yeah, thank you. Yeah, take care, Stefan.